Okay, hi Year 10. Welcome to your introduction videos for this week. We're going to be doing some probability work, and we're going to be doing some, much more advanced actually than you may have done in the past. But we're going to remind ourselves of what we mean by a sample space diagram. And we've talked about that many times, and we're going to talk about the different types of sample space diagrams again. And then we're going to introduce the idea of a tree diagram, which is another form of a sample space diagram that can be very useful for certain situations. Okay, let's just crack on. So I've got a question here. It says I roll a normal unbiased dice, so dice with 1 to 6 on it, and each outcome is equally as likely as the other, and flip a normal unbiased UK coin with tails and head on either side at the same time. What is the probability that I get a head and a tail? Well, one way of answering a question like this is we just do a simple list for my sample space diagram. If we remember what a sample space diagram is a way of representing all of the outcomes from something happening. So you can flip a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6, or a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. So this is my sample space diagram. Sample space diagram, because it lists out everything that could possibly happen. Okay, and now all I need to do is work out the probability of getting a head and a 5. Well, you'll notice there's only one head and 5 out of 12 things that could happen impossible. So the probability of getting a head, I'm just going to use this notation here, and a 5 is equal to 1 out of 12. So the sample space diagram is really, really useful, because it will tell us the total number of outcomes that could possibly happen. That should be the denominator. And then the number of successful outcomes to suit what you're looking for is going to be the numerator. So very, very easy. Sometimes a simple list is the best sample space diagram. Okay. The problem with this approach is it only really works if each outcome is as equally likely as the other. Okay, each outcome here is as equally likely as the other, which, as we'll see later, is not always the case. Okay, but here is another case where each outcome is as likely as the other. Okay, so I roll 2 normal unbiased 6-sided dice. I add the numbers together on my dice. What is the probability I score 5? What's the probability I score a square number? What's the probability I score a prime number? So again, a way of doing a sample space diagram here is make a table. So here is my sample space diagram. Okay, and again, so these are the outcomes from the first dice. These are the outcomes, other way around, first and second dice. So in this blue box here, just to make it abundantly clear, these are the outcomes that I can get. Remember, what I was asked to do is add the scores up. Okay, so I can now clearly see that there are 36 possible outcomes. So the denominator of my fractions is always going to be 36. So what were the actual questions? What's the probability I score 5? So the probability of scoring a 5 is equal to 1, 2, 3, 4 out of 36. Now I can simplify that if I want to. In probability, you don't have to. Okay, unless the question says that you need to simplify it, you don't need to. So I'm not going to bother. Probability I score a square number. So the probability, you look at the notation I'm using. Probability of getting a square number saves me time having to write out the probability of all the time, is equal to square numbers. So that would be 1, 4 and 9. 16 is not possible, so there's no 1 either. So it's 1, 2, 3 for the 4s, and 1, 2, 3, 4 for the 9s. So basically it's 4 or 9, So it's going to be adding them together. So that's 3 plus 4 is 7 over 36. This is the probability of getting a 4 or of getting a 9. Okay, listen to the words I'm using there. I'm using the words and, I'm using the words or. Okay, that's really, really important. Okay, and next one, what's the probability I score a prime number? So what prime numbers do we have here? We have 2, we have 3, we have 5, we have 7, and we have 11. So I need all of those. Okay, it's going to be quite high, isn't it? Okay, so it's the probability of getting a 2 or a 3 or a 5 or a 7 or an 11. So I'm going to add up all of those. So that's 1 plus 2 is 3, plus 4 is 7, plus 6 7s is 13, plus 2 11s is 15. So the probability of getting a prime number score is equal to 15 over 36. And again, I can simplify it if I want to, but I don't have to unless the question says so. Okay, so there's another type of sample space diagram. Just a table. Okay, but again, what is the disadvantage of this type of sample space diagram is that it means each of these outcomes has to be as likely as the other. So the probability of getting this 8 has to be exactly the same probability of getting this 3, for example. Okay? So the advantage of it is nice and easy, but disadvantage is we can only deal with it when we understand that each of these outcomes is as likely as the other one. Okay? Might not always be the case. Now, for example, so we'll get to that in a second. We've got sample space diagrams come in many forms. So we've talked about a simple list. We've talked about tables. Now, we've also got Venn diagrams and tree diagrams. Now, let's just talk about the difference between a Venn diagram and tree diagrams and simple lists and tables. Now, what these are, these assume that each outcome is as equally likely as the others. Okay, so for example, if I go to my simple list, this outcome is just as likely as this outcome. And this outcome is just as likely as this outcome. Okay? Same with my sample, table. This outcome is just as likely as this outcome. But with Venn diagrams, and we're going to get to it, tree diagrams, these can be for situations where that's not the case. So here it's not necessary, it's not necessary for each outcome to be as likely as the other. Okay? That's the same for a Venn diagram and a tree diagram. So they're more useful, more flexible, more useful for different types of situations. Okay? I'm going to stop the video there, and we'll talk about Venn diagrams in the next video before we then move on to talking about what a tree